Center for the Ethiopian Educational Information and Communication Technology presents Educational Satellite Television Programs.
Hello, teacher. Hello, students. Welcome to today's lesson on vectors and scalars. In the last lesson, we reviewed the definition of vectors and scalars. We also reviewed coordinate and column vectors, as well as how to calculate a vector's magnitude. Today, we are going to review the addition, subtraction, and multiplication of scalars. This will be a reminder of what you have learned in the previous grade. It will be important to have a firm grasp of functions of vectors as we continue this unit. Are you ready, students? We will begin with the addition of vectors by reviewing the tail-to-tip rule. If u and v are any two vectors, we can determine their sum by translating v so that its initial point coincides with the terminal point of u. Try applying this rule yourselves, students. Let us say that vector v represents a displacement of 8 meters to the north. Vector u represents a displacement of 6 meters to the east. Please use the tail-to-tip rule and find the sum of these vectors for their combined displacement. Go ahead now.
Students, let's get ready. Begin. Time's up. Let's get back to our lesson.
Welcome back. I am sure that you had no trouble with this review question. When we apply the tail-to-tip rule, it changes our graph to look like this. The resulting shape looks like two sides of a right-angled triangle, does it not? That means that the square root of the sum of the squares of the two vectors will give us our total displacement. In this case, the total displacement is equal to 10, as you can see here. Since u and v so closely resemble two of the sides of a triangle, this is called the triangle law of vector addition. We can also add vectors by adding their components. Here are the components of 4 vectors. They are called A, B, C, and D. Please find the sum of A and B and the sum of B and C. You may get started now, students.
Students, let's get ready. Begin. Time's up. Let's get back to our lesson.
Hello, students. Were you able to add these vectors by their components? We can find the sum of each vector pair by adding their respective components. Vector A equals 3 and 1, and B equals -2 and 4. Therefore, their sum equals 1 and 5. Similarly, the sum of 10 and 8 is 18, and the sum of 6 and -2 is 4. Therefore, the sum of vectors C and D is 18 and 4. I am confident that you had no trouble adding these vectors by their components. The components of vector U are 4, 3. The components of vector V are 1, 5. Try to find the sum of U and V.
Students, let's get ready. Begin. Time's up. Let's get back to our lesson.
Did you manage to add the vectors? I am confident you had no trouble. Remember, we must add the x components and the y components respectively. 4 plus 1 equals 5, and 3 plus 5 equals 8. Therefore, the sum of vector u and vector v has the components 5, 8. Here is another example. From the origin point, we can draw a horizontal vector to point A of length u. From point A, we can draw a vertical vector of length v. Our result looks like this. You can see that if we draw vector v from the origin, then draw vector u from v's terminal point, we are left with an identical result. Therefore, we can conclude that u plus v yields the same sum as v plus u. This is known as the parallelogram law of vector addition. Students, we can apply these two laws to discover an additional property of vectors. Observe this graph. You can see that vector u runs between points O and A. Vector v runs between points A and B. Vector w runs between points B and C. If we find the sum of all three vectors, the result is a new vector that runs between point O and point C. If the sum of any two vectors is added to the third, the result is the same. This is called the associative property of vector addition. We have reviewed the triangle law, the parallelogram law, and now the associative properties of vectors. By applying these correctly, we can not only find the sum of any two vectors, but the difference between them as well. The rules of arithmetic states that if W is the sum of U and V, then U is the difference of W and V. That is to say, U is equal to W minus V. Now, let us be reminded how to multiply a vector by a scalar. Multiplication by a scalar is formally defined this way. V is a non-zero vector, and K is a non-zero scalar. The product KV is the vector whose length is magnitude K times the length of V, and whose direction is the same as V if K is greater than 0. The direction will be opposite if K is less than 0. Remember that a scalar expresses magnitude, while a vector expresses both magnitude and direction. Therefore, if a vector is multiplied by a positive scalar, the magnitude will be altered, not the direction. Let us see how well you remember this technique, students. Here is a vector. As you can see, it is defined by the coordinates 3, 6. Please multiply this vector by the following three scalars and graph your result. You can get started now, everyone.
Students, let's get ready. Begin. Time's up! Let's get back to our lesson.
Hello again, students. Once more, I am confident that you had no difficulty in recalling what you learned in the previous grade. The first scalar is equal to 3. Therefore, you must triple the magnitude of the vector until its terminal point comes to rest at 918. The second scalar is equal to 2 over 3. Therefore, the magnitude of the resulting vector is 2/3 that of the original. The terminal point rests at 2, 4. The third scalar is more difficult, being equal to -5 over 3. Therefore, the direction of the resulting vector opposes the original, and it is 2/3 again as long. The terminal point rests at -5, -10. Were those your answers, students? Good work. I can tell that you remember the multiplication of vectors by scalars. That is all for today's lesson. We have reviewed the addition, subtraction, and multiplication of vectors. We have also been reminded of the triangle and parallelogram laws. In the next lesson, we will learn how to resolve a vector into its given components and how to express it in terms of unit vectors. Until next time, thank you, teacher. Thank you, students.